Janice, read the question. Janice, are you there? Safo?
Yes, please.
Read the question.
Two particles P and Q are shot vertically out. Particle P is first up with a velocity of 40 meters per second.
Mr. Dia.
Safo is reading. Safo, go ahead.
After, after 4 seconds, particle Q is also shot out. Find A where the two particles meet. If a point of meeting P has a velocity of 50 meters per second. B the velocity of the,
The
the
velocity with which, go
which
ahead.
Q is short. Gravity equals to 10 meters per second squared.
Okay, so here it's about two particles, P and Q, and both are shot vertically up. Okay. Particle P is first up with a velocity of 4 meters per second. So let's assume that both particles are being shot from this level, P and Q. Now, P was shot first with a velocity of 40 meters per second. So this was shot first. This is P with a velocity of 40. Then after 4 seconds, particle Q is also shot up. This is particle Q. Its initial velocity, we don't know. Find A, where the two particles meet. If at the point of meeting, P has a velocity of 15 meters per second, then B, the velocity with which Q is short when gravity is 10. So we have to find the point where the two particles would meet. Now, what do we mean by would meet? Two particles are being thrown vertically upwards. Let's assume this is P, this is Q. This was shot earlier, and 4 seconds later, Q was also shot. So this started going first. Please hold on, I'm coming. Hello? Hello?
Hello, Mr. Dia.
So, Savo, are you there?
Yes, please.
So, this is P, this is Q. Because this is short earlier, they cannot meet when they are going because always one is in the lead. Now, because this is short earlier, when P gets to the maximum height and it is returning back, that is the point where they can meet because this is earlier short before this one. So they can only meet when the first one gets to the maximum height and it is descending. Then it can meet at the same point with Q. Is that okay? Is that okay?
Yes, please.
So the only point where they can meet is when the first one, which was short earlier, gets to the maximum height and it is returning back, then they can cross. All right. 2. Don't forget that P was short earlier and 4 seconds later, Q was short. P was short first and 4 seconds later, Q was short. So when we are looking at the time, it means that the time for P always leads Q by 4 seconds. These questions are said that you need to understand every statement that is made. P was short and 4 seconds later, Q was also short. So in terms of time, at every position of the two bodies, the time for P leads Q by 4 seconds. Is that understood?
Yes, please.
So let's look at the diagram. So if let's assume this is the path of Q at P. This is the maximum height reached by P. And then we are assuming that this is the point where the two particles meet. So this is Q. They are meeting at this point. Now, it means that if you are calculating for the total time for P, it must be the time taken to reach the maximum height plus the time taken to reach this height or this point. Are we okay? And at every time, the time for TP, okay, is 4 times greater than the time for Q because P was short before. So if we are calculating for the time for P at any time, it will be 4 plus the time of Q because P was short and after 4 seconds later, Q was also short. Are we okay? Are we okay? So if we are assuming the time for T is P is
Yes.
T, the time for Q must be equal to time of P minus 4 because P leads Q by 4 seconds. All right. Now let's determine the time taken for P to reach the maximum height. We are told that the initial velocity of P, UP, is 40 meters per second. So let's calculate the maximum height reached by P, H max reached by P, and also the time taken for P to reach the maximum height. So if U of P is 40, help me determine the maximum height reached by P and the time taken for P to reach the maximum height. Are you okay? Are you okay?
Yes, please.
We know we know the initial velocity of P. We are told is 40. So if we know the initial velocity, then we can find the time taken for P to reach the maximum height, and then the maximum height reached by P. So first help me determine these quantities, then we move on. So what have you had for the maximum height reached by P?
Sir, please, 80 meters.
So maximum height reached by P. So what did you also get?
80 meters.
Okay, so then clearly it means you use U square over 2G. So we have 40 squared over 20. And this is 80 meters. So it means that's the maximum height reached by P. What did you also make for the time taken to reach the maximum height?
It's 4 seconds.
Sir, please,
How
4
many?
seconds.
Okay, so time taken
Second.
by P to reach the maximum height is also U over G. So 40 divided by 10, which is 4 seconds. Okay, so look at something. So look at something, if P has to fall from where the ground, from the ground to the maximum height, then return back to the ground, what will be the total height? What will be the total distance or displacement taken by P if it has to move from the ground, reach the maximum height, and fall back to the ground? What will be the total distance?
160 meters.
So 80 times 80, or 80 plus, sorry, 80 times 2 or 80 plus 80. Now look at something. So from the ground to the maximum height is the same as from the maximum height over here. Meaning, if I want this distance from the maximum height to where they are crossing each other, and let's assume that that is h. If I could get this distance, if I could determine this distance, I must subtract it from what? I must subtract this distance y from what? Hello?
Please, from 80.
From 80. That, you see, that is the reasoning I want you to put into the calculation. Okay, the same height, whether it's going up or coming down. Okay, so if you're able to determine this, you could easily find h, meaning they'll cross each other at this height. Now, when it is falling back, p is falling back, this is free falling, and you know the velocity at this point, u is equal to 0, because p is free falling. The question also told you that, listen, find a, listen, find a where the two particles meet. If at the point of meeting, p has velocity of 15 meters per second. Find a where the two, so we are looking for where h, where the two particles meet. If at the point of meeting, p has velocity of 15 meters per second. So if at the point where the two are meeting, particle p has a velocity 15 meters per second. So we know the final velocity of p. We know because p is free falling when it is returning downwards, we know the initial velocity. Can't we use that idea to find y? Can't we use that to find y?
Please, we can.
Start work. Sappho, respond to my probing. Start work. It's similar to the last question we solved. Very, very similar. Then if you're able to find y, then you calculate the height where they cross for me. What have you had for y?
Sir, please. I got 11.25 meters.
So find, Sappho, what did you also get?
Sir, please, I'm not done.
So, Janice, if you found y, find h. How far you through? How far you through?
Yes, please.
What did you make for y? Sappho, what did you make for y?
Sir, please. 80.
How did you do it? You are looking for y, where the point where they are crossing. So how did you do it? Before, that is the vertical distance traveled by P before it crossed Q. So how did you do it? Yanis, how did you do it?
Sir, please, I found y by using the formula v square is equal to u square plus 2gh.
That is one way to look at it. The other way is to use h is equal to ut plus half gt squared. So if you are going by what Janice used, v squared is equal to u squared plus 2gh. Here, 2gy. Please, this is similar to one of the questions we've solved. So y would be equal to u is 0. So v squared over 2g. At the point of crossing, the velocity of p, we are told, is it 15? John, is it 15?
Yes, please.
So 15 squared over 20. And what is 15 squared? I think 225.
Yes, please.
So 225 divided by 20.
11
What's
point
11 points?
5
11 points.
25.
So as at when P crosses with Q, it has traveled 11.25 meters from the maximum height. If you are to use the other formula, H is equal to free falling. Okay, but here you need T, half gt squared. So you need to use the first equation to find T, which will be T will be equal to V over G, because U is 0. V is 15 divided by 10. You have 1.5 seconds. So it means that as at when P crosses with Q, it has traveled this time from the maximum height. So if I substitute this T into this equation, we have half times 10 times 1.5 squared. This is equal to 5 times 1.5 squared. Then it's calculated for me. 5 times 1.5 squared. The same value, 11.25. Correct?
Yes, please.
So for this is how to go about y. Now, if you know y, you can easily find the height where the two bodies will cross. Okay, meaning P has to travel 11.25 and Q has to travel 11.25 from the maximum height to cross it, and Q, so they will be at the same level from the ground. So knowing the maximum height to be 80, H will therefore be equal to 80 minus 11.25. And this is equal to what?
68.75.
68.75 meters. It's not a difficult question, but if you don't think through it, you won't know. Okay. The second question. B. Calculate or find the velocity with which KO is short. Find the velocity with which KO is short when gravity is 10 meters per second squared. Start with, think through. I'll leave this for you. Think through and then discuss it with me. Back to you. Yes. How are you determining the velocity of projection of U? How are you calculating for the velocity of projection of U? Yes, respond to me. How are you determining U? Who starts?
So please, being equal to square root of 2gh.
U is equal to square root of U is equal to
Did you say v or u?
you are to determine the velocity of projection of KO U. So the initial velocity of U, of KO is what we are looking for. We are given the initial velocity of P 40, but we don't know the initial velocity of KO, and that is what we are to calculate for. Janice, I'm listening to you.
Sir, please, I'm still solving.
How are you determining it? How? What is the approach? What approach are you employing to find U? Janice, I'm listening to you.
Sir, please, U is equal to square root of 2gh.
U is equal to square root of square root of 2gh. And this is coming from the formula. Yes. This is coming from the formula.
H is equal to 2 square, U square
Over 2g. Okay. My question to both of you is that when do we use this? When do we use this formula? So for you first, when do we use this formula? Safo,
You should are looking for the height.
which height?
It's the downward.
Okay. Janice, when do we use this formula?
Sir, when you are finding the maximum height.
So in this situation, what must be the direction of the body?
It is going up.
Going up. Good. So vertically upward motion. Okay. So if you want to use this to find u, what of Q must you know before? What of Q must you know before you use this?
Please, the height.
The don't say height, maximum height, because this is used for maximum height. H here is not just any height, maximum height. So it means that if you don't know the maximum height of Q, you can't use this. Now, the maximum height of a body depends on its initial velocity. So if the initial velocity of P is 40, and let's say the initial velocity of Q is 50, you don't expect the same maximum height. So you can't simply use this when you don't know the maximum height of Q. The best relation you can use is that you don't know the maximum height, so use at any height h. At any height h traveled by Q, h will be equal to what? Ut minus half gt squared. At any height h. Okay, now you calculated 4. Do we have h? Yes. We have found that the height where the two bodies cross each other, h. And then the time. So this is the height from the ground where the two bodies would cross each other. Then the time where the two bodies would also cross each other will be 1.5, which we calculated here. Meaning, by the time they cross, Q will travel 1.5 from the maximum height. Okay, and the same height is what P would also take. So this 1.5 connects to a height of 11.25. So you have H, you have T to find U. So this is the relation to use in determining U once you don't know the maximum height. If you have the maximum height, then this will help you. But once you don't know the maximum height traveled by Q, this is the relation to go by. Please, are you okay?
No, please.
You are looking for the velocity of projection. This formula tells you that when the body is going up at any height or distance, vertical distance traveled, this is the relation to help you get h. Okay, at any vertical height traveled, h. Knowing the time, this is what you use to find the vertical height traveled. Now, so this is at any time t or at any height. When it gets to the maximum height, because you know v is 0, then you can use this. That's why you said this is for maximum height, because you know that at the maximum height, V is 0. So you can get this relation. Okay. Now, as the body has never gotten to the maximum height, velocity has not reduced to 0. So this is the relation to use in determining h. U is what you are looking for. H we know because we are looking at when they are crossing at a height 68.75. The time we know because when we calculated, we saw that they will cross each other at a time of 1.5 seconds. Okay, so once you know H, you know T, gravity is constant. Can't you find U? Can't you find U?
Yes, we can.
So go ahead and find U. You have T, you have H. All right, so I think we'll end here. I'll forward the question to you so that you do it and send it to me, okay? Okay.
Yes, please.
All right, so bye-bye.